Well, welcome everybody to the Sarah Radio Telescope Observation Party for April. Uh, if a lot of you know that we have in the Western Conference in Dallas tomorrow and the next day. That's going to be broken up with the people running out to try to find the eclipse. There might be a problem with clouds right now. They're still determining, but if there are clouds, people vow they're going to go run up and down the highway until they find a cloudless spot, so they can watch the eclipse. Other things going on is the journal is journal entries are due by the 12th of April. So if you've got a journal entry, and I'm also looking for any eclipse photos you guys got, if you want to send your observed eclipse photo, I'll make a page for all the eclipse observations. And anybody who's got like a super SID and detects the or any of the other radio telescopes that detects the eclipse, I'd like to see those too. Just make a quick one pager, what you got it with, and what you think you got, see if you got the eclipse. I was able to get the 2017 eclipse with my super SID, just because of the geometry I was to where the eclipse was happening to the transmitter. So it is possible to see it on super SID. Also, I might ask, get a couple of you guys to review our entry to the ARRL engineering book. They've asked for that by April 15th. I've got a draft, and I'm going to send it to a few people, especially people that I've chosen papers for, and you guys can look it over and beat it up, and and hopefully we can get that in. Let's see. Anybody else have any announcements real quick? And I'll just go on to, let's go to Edward.
Hi. I don't have anything this month to show in this meeting, actually.
Okay. Well, great to have you. Wolfgang.
Yeah, I will skip myself also because what we have to tell will be done by Vanessa. She will take it over for our team for tonight.
Oh, okay. Well, let's go to Vanessa then.
Yeah, hello. So I'm gonna share my screen.
Okay.
So we've been working on our interferometer with the antennas. So we have mounted them at the back of our garage. So they're approximately in an east-west positioning. And you can see that we have mounted 3 of them so far. So in the beginning, we only had the far east and the far west antenna mounted. So we had a very long baseline of the 10 meters. So this was also used for a first light. And then we mounted the one in the middle. And the signal of the middle antenna is split. So we have 2 baselines, the long one with 7.7 meters, and then a shorter one with the 2.2 meters. So at the moment, we're only working with 2 baselines, but the ultimate goal will be that we'll have all the 3 baselines, that we can collect the data simultaneously of all the 3 and compare the data of those. So this was our first light that we had. So you can already see that we have some kind of modulation here. So the question was if it is maybe a problem of cable matching or multipath interference, suggested in the forum by one of you guys. So we checked yesterday with the cables and matched them all, but apparently the signal today looked the same as those 2. So this is the short baseline of 2.2 in the bottom, and in the top it's the longer one. And apparently it's not a problem of the cables, but more likely one with the multipath interference from the ground. but that's going to be a little tricky to model because our ground is not, so it's a little hilly there, so it cannot be modeled very easily. And yeah, that's the current status of our interferometer. And the next goal will be to maybe change the elevation and check if the ground reflection then disappears. And then also get the third baseline working. That's all. If you have any questions or ideas to improve, then you're welcome to share.
Yeah, I have a question. What were you observing? The sun? Is that?
Yes, we're observing the sun.
All right, any more questions?
Yeah, what type of LNAs were you using for those?
Pablo, we could barely hear you.
Sorry about that. It helps if you have the microphone close to your mouth. Now I know. What kind of LNAs were you using for those antennas?
I guess it's the Noelic ones, right, Wolfgang?
Yes, these are NOLEC ones with the integrated filter. So we are observing at actually the center frequencies for 1419. And I should mention that we are using different bandwidths. We made experiments with different bandwidths. So we can, because of the SDR, we can choose the bandwidth anywhere between small up to 10 megahertz.
Yeah, and the data here is with 10 megahertz.
Are you electronically combining the baselines, or are you just manually combining them in
So we get the IQ data and then we do a complex conjugation of those and then we correlate them afterwards.
And if you combined all three of them simultaneously, is that one of the inputs here? All three baselines?
So at the moment, we are collecting the data separately for both of them. The problem is that we only have 2 SDRs at the moment.
Okay.
So we have to check how the phase is between those 2 Pluto's changes.
Well, the idea is that the third baseline will be calculated also by the 2 Plutos. The scheme that we want to build is somewhat similar to what has been discussed on the forum as the scheme of the Kraken SDR, where you use a reference signal to correlate different receivers. And this is what we are working on. And the finding so far is that that should be doable at lower bandwidth. There may be a problem, which we still have to identify if we go to higher bandwidth, that the correlation between the 2 different Plutos is not stable. But we're working on that one, because we need to have something to tell at a different meeting again.
All right, that looks great. Anybody have any more questions? Okay, excellent work. Thanks, Vanessa.
Thank you.
Let's see, Charles Weaver. Oh, I don't have him. Let's go, Rick.
I'm just listening today.
Nothing today? Okay. Let's see. Pablo, how's your how many planets have you discovered lately?
I observed an exoplanet last night, and I have to reduce the data, and send it to.
Get your mic again. I'm sorry. Still can't hear you.
Can you hear me now?
Yeah, there you go.
Oh, sorry about that. I'm weak, I guess. Weak-minded. Anyway, I observed an exoplanet last night, and I have to reduce the data just now after this meeting and submit it to the TESS sub group. And so I've been doing that as the weather clears. Nothing really to report radio astronomy wise. I still have my 2.1 meter dish, and I'm trying to replace the old computer for a new one and upgrade it, but that's going to take a while. So just doing exoplanet work and observing near Earth objects, trying to find the one that it's going to destroy planet Earth, so they can put my name on it. Hopefully not. With my luck, the one that I find and they put my name on it, that's the one that's going to destroy the planet. Anyway, hopefully not.
So it'd be Pablo Biederman. Is that what I understand?
Exactly. Yeah, the
All right.
destructor.
Okay. Okay, Jason.
Yeah, so I actually have some good stuff to show today. So
Great.
I'm gonna go ahead and share my screen. Yeah, there we go. And let's start this. So as you may or may not know, I've been trying to detect the hydrogen line emissions from M31, specifically the blue shifted one that's well clear of the local hydrogen signal from the Milky Way. And ever since I saw JJ Manto's paper where he managed to detect both M31 and M33 in the hydrogen line using a relatively small dish, I was like, okay, it's possible. Now I'm really committed. And so it's been a 2-year process of trying to get my dish performing well enough to actually do it. Yeah, this last couple of weeks, I succeeded in detecting M31, and I went ahead and actually also did M33. And just yesterday, I got a clear profile from M33. So I'll kind of go through it here. And the idea was to do it with a portable dish in my backyard with drift scans only. So I'm not tracking. I'm literally just doing drift scans and combining the data. So this is my setup. It's a giant umbrella type dish. It's 2.64 meters, about 9 feet in diameter. It's covered with Faraday fabric, and the structure is built from plywood and PVC pipe. And the feed is a one of the circular feeds with the choke ring to reduce ground noise. And I'm using a Newelec Smart T SDR and a Newelec Sawbird H1 filter and LNA. And then I was actually playing around with both the Ezra collection utility and SDR Sharp's IF averaging. And I ended up going with the SDR Sharp IF averaging simply because for some reason the Ezra collecting utility was not really collecting as many integrations per unit time as it should have been. It was reduced by a factor of almost 4. And so I got to look into that and see what's going on there. So I was wanting to maximize the amount of samples I was getting per unit time because I'm limited by literally by the Earth's motion. So I wanted to maximize my time on target with the drift scan. Anyway, and then I just used Excel to do my data processing. So this is my setup. This is a reference figure from J.J. Manto's paper, just to show the region I'm looking at. Let's see, is this. I don't know if you can see my cursor. The center of the region is approximately declination 40 degrees north and right ascension 39 minutes. And so that's where I was centering my observation. My beam width, according to my sun test, is around 7 degrees, possibly slightly smaller than that. And so that's kind of what I used as my guide when I was preparing my observation plan. So here's an illustration. I used my Stellarium iPhone app to create these nice little images. So the red circle is the approximate beam field of view of my dish, and then the green circle is the kind of the region I'm looking at in M31 Andromeda. And so the pre-scan, what I did was I did a pre-scan for 30 minutes. Then there was a 5-minute gap. Then I did my main scan for 30 minutes. And then a 5-minute gap, and then a post scan. And then what I did is I used the pre and post and averaged them together and used that as my calibration for the system, rather than using either an out of band scan or a 50 ohm termination load. I calibrated against off target sky is what I did, and it actually worked well. So here's my my combination of 8 days worth of observations on M31. This is the raw data, both smooth. I did a smoothing where I took I basically averaged every 5 samples in the frequency bin to smooth it, and then I've got the raw data as well. And then I used a flattening function to flatten the response, and so I've got the reference profile on the top and my data on the bottom, and you can clearly see the blue shifted peak has emerged from the data. So that was very satisfying, to say the least. And the vertical scale is in dB above background, so you can see it's a very, very, very small signal. It's in the thousandths of dB. And actually, one of the things that JJ's paper helped me out with is I was able to use some of his sensitivity calculations to kind of estimate what my signal strength was expected to be, so I knew if I was even in the ballpark. And based on comparing my aperture to his and scaling the temperature accordingly, I kind of estimated that my expected temperature was going to be about half what his was. And then using my Milky Way observations and kind of correlating that to how the dB above ground noise or above background correlates to approximate temperature, I figured my my signal strength should be in the neighborhood of a couple thousandths of a dB, and that's exactly what I'm seeing. So so then I switched to M33, and so I just basically used bricks and plywood to tilt my dish 8 degrees to the south. From my latitude, that puts me right on target for M33, which is triangulum. And then I did use the same method. So now you're going to notice it moves the opposite way across my screen because now I'm facing south instead of north. At my latitude, M31 passes 1 degree north of my zenith, and so and then M33 is 8 degrees south of zenith. So I did my pre-scan, my main scan, and my post-scan, and with just 2 days worth of collection, this is my raw data, this is my flattened data, and you can clearly see the Batman signal showing up there, the 2 peaks. Interestingly enough, M33 is separated from the local signal enough that you can actually see the redshifted peak without a lot of problem. And also, because I'm using pre and post scans as my reference for calibration, it doesn't remove all of it, but it does remove quite a bit of the local signal because it's there in the reference scan as well as the main scan. And my next project is going to be to try to get the redshifted peak of M31, which will be a little more challenging because it is largely buried in the local signal. But yeah, the M33, I was just blown away by how clear it showed up after just 2 days worth. I mean, this is less than an hour. This is probably like 50 minutes worth of total integration time, and I'm already seeing a clear profile showing up. It's amazing. So anyway, I'm hoping that my efforts will encourage other people to try doing it with drift scans as well, because as far as I know, nobody's done this with a small dish with drift scans. JJ actually was tracking, and he was on it for like 3 hours. Now, granted, he was doing a more detailed survey, so he was getting a lot cleaner data, and he also had a lot better receiver setup than I did. My goal was to do this with stuff from the hardware store, in my backyard with drift scans, and I was really pleased with how it turned out. So anyway, that's all I got for today. And I guess I'll stop sharing now, but anybody got any questions for me, or
go back to your slide?
Okay.
With your data. I just got a couple questions of go to like your M31 first. I just want to make sure I'm seeing what you described it, but I wasn't sure that I was seeing the data that you were pointing out. Okay, go to the next one.
Mm-hmm.
Okay, now are you saying the first bump on the bottom red chart is the detection?
Yeah, and one of the biggest problems that I'm having, especially with M31, because it's so spread out spectrum wise, is one of the biggest problems isn't actually the background noise, it's stability of the receiver across the bandwidth. And what I'm getting is it's moving all over the place. And so as I take additional scans and average them together, what I'm hoping is that movement of the response will kind of average out. But what you're seeing off to the right is basically the response of the receiver is not flat. It's curving up.
Okay.
But and what I'm not showing here is if you look at multiple days, if you look at each individual day's worth of data, you can definitely see, no matter what the broad response is looking like, there's always a peak at 525. There's always in it. It doesn't matter what else is happening. So that peak is definitely a constant. The rest of the response is kind of moving all over the place. What was surprising to me was M33 is half the size of the signal, but it's clearer, and I think it's because it's a narrower bandwidth signal, and both of the peaks are there within a smaller span. And so I think for some reason it was showing up a lot clearer even with just 2 days worth of data collection. So
okay.
The other thing that I did purposely was I offset my center frequency. I didn't put I didn't put minus 525 kilometers per second in the center of the receiver, because I wanted to make sure that I wasn't getting a peak just from the receiver response. And so I purposely put it offset so that I would know for sure if I see something there, it's it, right?
Okay. Yeah, go to M33 and okay, so the first big bump is is your detection.
Yeah,
And what's
well,
the
so you can actually see both of them. There's kind of like there's one at 260, and then there's one at 110, and then there's kind of a raised area in the center. And
why is that physically?
so what you have is you have the galaxy spinning, and so you get the side that's spinning towards us blue shifting it, and the side that's spinning away from us red shifting it. So you get a single peak that's split. And that, if you look at survey data, one of the coolest papers I saw was from the 90s where they had done a survey of a bunch of galaxies using the Arecibo, and every single one of them looks like this. I kind of like to say they look like a Batman signal. They have the two horns and the flat in the middle. And that's one of the things too that I think is the strong evidence for dark matter is if it was a Keplerian velocity profile across the disk, you wouldn't have two sharp peaks. You would have more of a broad thing, right? But you get these two sharp peaks because you have almost constant flat velocity profile across the disk, right? Which is pretty wild. And I expect, you know, when I gather a good week's worth of data, this thing is going to clear up even more. So.
Okay, Edward, did you have a question? You got your mic off.
Yeah. I just wanted to say, yeah, really nice work. Well done. Actually, I did a couple of observations of M31 and M33 with my 3-meter dish a couple of years ago in exactly the same way.
With drift scanning?
Yes, with drift scanning.
Wow,
And then
cool.
taking spectra before and after the transit and using those as the calibration, and then also averaging over multiple days.
Yeah.
Yeah, maybe if you want, I can show you so you can compare.
Oh yeah, cool. So what size was your dish?
3 meters.
3 meters. Okay, so you're slightly larger than mine, but
And
Yeah,
get a little closer to your mic there, Edward, too. You're a little light on voice.
okay. Am I clearer now?
Yeah, a little better.
yeah.
Okay.
So what's the beam width of your 3 meter dish then? Half power beam.
At that time, it was about 5 degrees.
So you had like maybe 20 minutes on per day, something like that.
And I can also confirm that in my case, M33 was also a bit easier to detect despite it being weaker. I think also for the same reason, because it's like a more concentrated in a smaller part of the spectrum, like Andromeda is extremely spread out. So it's very difficult to get all the background flat.
Yeah. Well, that's cool. That's yeah, I'd be really interested in seeing your results as well. So
okay, shall I share my screen?
sure.
I have them.
I'm gonna stop mine now here. Yeah, there we go.
All right, so this was M31. Can you see?
Yeah.
Okay, yeah. So yeah, you can see then the blue shifted peak, and then also some of the red shifted emission as well. And then M33.
What was the bandwidth of your receiver for that?
6 megahertz.
Okay, yeah. See, I'm using the Newelec Smart T, so I'm limited to 3.2 megahertz. So I can't get all of M31; it just won't fit. So what I'm planning to do is just do it in two separate sets of observation and then just combine them together.
Okay. Yeah. This was M33 from last year. It's not as good because the dish has degraded a bit. It has deformed a bit over time.
Oh, okay.
But you can, yeah, but you can still sort of see the double horn profile, but the signal to noise ratio is very low here.
Yeah. What was how many frequency bins are you using?
I don't remember exactly, but I think I had a resolution of something like 30 kilohertz. So very
Okay,
wide.
yeah.
Because
Yeah, I was using 128 bins across 33.2 megahertz. So, and then I was still smoothing my data after that, so I was even reducing it from that. But and is this with just one observing session, or is this several drift scans combined together?
if I remember correctly, these were 2 or 3.
Okay,
Not
yeah.
more than
So
that.
I was so surprised. Even after one, I could clearly see that it was starting to appear. And what I showed on my paper or on my PowerPoint presentation was just 2 days. So literally 50 minutes, 45 or 50 minutes on target at most. So which was I couldn't believe how good M33 showed up. I mean, it was just I was ecstatic with how good the results were. So, wow, it's neat to see that somebody else has also done it. So,
Yeah, and for me, it's also good confirmation that like this is indeed possible, and the
yeah,
signals that we are seeing are real. Like
yeah,
that's pretty cool. Yeah. Okay. Thank you.
yep. Thank you.
Great. And Jason, if you want to think about, if you want to send me that, I can put that in the journal under observations. Your PowerPoint slide. If you're ready. Yeah, you're on mute, but that's okay.
So just the PowerPoint slide the way it is, or
that's fine with me for I mean for the 12th. That's unless you want
yeah,
to do it.
I may add a couple more slides to show my setup for
That's
M33 and
perfectly great. Perfectly
okay,
great.
cool.
That'd be great. Okay.
Jason,
right.
just one question. If you mentioned that, but I don't recall your on-target time for those observations at your beam. With what was that again?
It was 30 minutes.
30 minutes, so 2
Half an
days.
hour.
That would give you 1 hour integration
Yeah.
time. Yeah. Okay.
Yep.
Yeah, that's pretty impressive because if you do the back of the envelope calculation, you find that observing these are at the limit of what you can do with the size of
Yeah.
dishes. So it's yeah, the number shows yes, it's doable, but it's at the edge. But congratulations on that.
Yeah, and what the other thing I did several days for M31. I did, I think, 8 days total. And one of the things that was really interesting to see is you could see in each in the combination of each, as you added successive days, you could see the the 1 over square root n rule coming into play. Like you could see the amplitude of the noise dropping by a factor of square root of n every
yeah
successive day. It was pretty neat. Like after 4 days, it literally dropped by half.
Yeah, that's radiometer equation at its work.
Yeah. It was just nice to confirm that it was actually doing what it was expected to do. So.
Jason?
Yeah.
Yes.
If you publish, can you include like parts lists for the things you had to buy, like Faraday cloth?
Yeah, and actually, I have Alex to thank for that. I originally used aluminum window screening, and it worked okay. But man, when I switched to the Faraday fabric, it made a huge difference. I mean, that stuff's amazing, and it wasn't that expensive. I mean, I think I spent like maybe $80, and it was like 260 some feet of it. to cover my dish, and I just stapled it on with with upholstery staples, and it worked fine. So,
I looked on Amazon, and there are a lot of different choices now for Faraday cloth. There used to be only a couple of vendors, and now there's a zillion. But
yeah, I will probably I'll include specific information on that. Basically, that's the only specialized material. Everything else I literally bought at my local home improvement store. Plywood, PVC pipe, nylon string. I used some nylon screws to hold my feed in position, because I didn't want any steel hardware interfering inside the field of view of the dish. But in the specialty hardware section of the store, they've got nylon machine screws and stuff. So I just bought a handful of those, and they work fine. So my idea was to go completely low tech, make it something that you could build for a few hundred, for a couple $100, and buy everything at the local hardware store. So,
well, and two, I wanted to say congratulations. You worked on this for, you said, over a year?
Yeah, well, I first got the idea for M33 2 years ago, and I've spent a long time trying to get my dish working properly, and then finally, when I got the dish performing well enough, then it didn't take very long to get the observation to work. I mean, when you're drift scanning and you don't have precise aiming hardware, you have to know what your beam width is, and you have to be able to know that your elevation setting is accurate, which the sun drift scans helped me to verify that my elevation setting was indeed accurate. I'm literally using a homemade protractor against the base, which is just plywood, and I'm just basically hanging a plumb line from that, and that's how I'm measuring my elevation, and it's accurate. I mean, it really does work. So, well, I guess I've probably taken my time now, so I'm ready to go on to anybody else. But any other questions? All right, thanks, everybody.
Excellent work. You set the standard for the M31, M33 stuff now, and everybody with their hydrogen measurements are going to be aiming at that. So I guess the question is that everybody's been doing drift scans now. Are they really picking up M31 or M33, and they just not noticing it?
Well, I think with those, unless you're and they're enough, most of the spectrum is enough outside of the local band. It's blue shifted quite fairly dramatically. So unless you're looking at that range, you're not going to see it.
So
especially with M31, because that blue shifted peak is way up higher in frequency. So
everybody's got a hydrogen thing. If they measure at what frequency center, they'll be able to pick up the 33 and 31.
So when I was doing M33, I set my center frequency at let's see, where is it? Around 1421.3.
Okay.
Which translates to about minus 185 kilometers per second. Now, one of the things I'm doing, I'm actually calculating the correction for the local standard of rest velocity, so that I correct my frequency before I do my observation. That way I don't have to do any post processing. I can just place my data right next to the previous days and the previous days. So I do the correction when I actually set up my observation frequency. So
Okay.
I do that calculation prior to my observation plan or during my observation plan. And the idea is then that I don't have to correct it later on. But yeah, and then for M31, I chose my center frequency at minus 425 kilometers per second, or which translates to like what was it? Center frequency of like 1422.4. And the reason I did that is because I wanted that blue shifted peak to be well within the flat bandwidth of my receiver, but not in the center, because I wanted it to be clear that I was seeing something that was real and not just the response of my receiver. So I didn't want to put it right in the center. So I put it kind of halfway between the edge and the center. And that seemed to work well.
So the scope in the box equipment that we provide, is there anything preventing anybody that has a scope in the box system from doing exactly what you did, or the filters too high or too low?
My thought would be that the aperture is just too small. I think you got to get up to close to 3 meters before you can get enough, because the antenna temperature is very dramatically affected by this, the size of your aperture. So, when my beam width is down around 6.5 or 7 degrees, if you get a scope in a box, you're up around maybe 15 or 20 degrees, and that's dramatically. That's you got your signal strength is going to be way severely limited by that. So yeah, I think that getting, and even in my homemade dish probably does not perform, its efficiency is probably fairly poor, but I traded efficiency for aperture, and the aperture is what matters in this, because you're looking at temperatures that are in the in the tenths of kelvins. So and if you go with a larger aperture, it's going to be down in the hundredths or thousandths of a Kelvin, which is that's too small.
Okay, so assuming that you get a bigger dish, does the electronics, the bandwidth, and the filtering size, so that, can we get up to that?
Yeah, I mean, I'm just using the standard scope. I mean, I'm using the Smart T, which is basically performs about the same as the SDR or RTL SDR V3, and then I'm just using the Sawbird H1 filter. So I'm not using anything fancy electronics wise. So I really think the thing that makes the difference is the aperture of the dish. And the thing is, if you get much larger than 3 meters, your beam width starts getting small enough that you don't have a lot of time on target with drift scanning. So it's sort of like this. You got to find this nice balance between aperture and time on target if you're trying to do it with a drift scan. Now, obviously, if you can track, then it doesn't matter. But I mean, at that point, you're almost getting into professional territory. And my idea was, let's do this without tracking, without any fancy equipment. How can we do this with drift scanning, and so, and it is possible. You just have to get a big enough aperture. So
maybe just a little support to what Jason just said. Let me share one quick thing, which is actually from a presentation from a Zara conference. So this is a calculation about the question: if you observe the hydrogen spectrum from M33, what is the limit? So this is a simulation with certain assumption as far as aperture efficiency and signal and noise temperature is concerned. But essentially what you see, the biggest is the 3.7 meter antenna. If you go to 2 meter, you're getting into very difficult terrain. And if you go beyond that, if you go lower like that, like the scope in the box antenna, you would be really, really down here. So I would say 2 meter is difficult but doable. Anything below that is getting almost impossible. So I think Jason did actually all the right things to do. I think his key of success as part of it is doing the pre-transit reference and the post-transit reference. And I would encourage people who would like to do that to follow exactly that scheme, because that makes a lot of sense to me, to iron out the variation of the response of the system. Because what's really hurting you is your spectrum is not flat, and you have to know what is your spectrum. And Jason did it by doing this 2 reference measurement, which I think is an excellent approach.
Yeah, the maddening thing is it's not flat and it's also not constant.
Yeah.
And when you're getting that small, tiny differences make a huge difference. And so it's like chasing a ghost, you know. And so the pre and post definitely did it. And the other thing that was interesting that I saw was the pre and post scan references also cut down the local signal quite a bit. They don't totally remove it, but they do reduce it quite a bit. And I'm assuming, Edward, that's what you saw as well, that it cut the local signal. Yeah.
So you could really see in those spectra that I showed that there's like some dips even in the local signal, because it's like getting mostly subtracted.
Okay, great. Thanks, Jason. John Richards.
Nothing to really report, except this morning, or last week, I saw on Facebook Marketplace a guy that lives 5 miles away from me. He's got a 14-foot fiberglass dish. He wants to give away for free and help dismantle it. So I went and looked at it. It was pretty nice. I mean, the dish was actually probably 30 years old, but it was all really high quality and no damage to it. So I may just go try to snag it, put it in the back, and plan for it sometime in the future when I get my current dish finished.
I'm curious. I'm curious.
A 9-foot dish. Oh, go ahead. Go ahead, Jason.
I'm just curious. What do they cover those fiberglass dishes with for the reflective surface?
I don't know. I was going to ask you guys that. But you wouldn't want just raw fiberglass, right? Or would you?
A lot of them are aluminized on the surface.
I couldn't tell. This, whatever it was probably over time, it's probably eroded somewhat away.
I was saying that the biggest problem I had when I accepted a 9-foot dish is the wind blowing it over.
Yeah.
So you have to really, wear that thing down.
Yeah. The only place I have for it is up in my woods, where I think there's enough clearance to get some visibility of what I want to see enough. But it's somewhat, wind protected. But yeah, I'll make sure that I have it really bolted down.
Well, have fun. Keep us up to date on how you get that.
Okay.
I just used nylon tie downs for mine. Just had some nylon string in paving stones, and it kept it from going over.
Yeah, I could do drift scan for my first try with it, so I don't have to worry about motors pointing it. It had an actuator, so it was actually, I guess the guy's dead now who originally put it up, so I couldn't ask him, but I assume it was for satellite reception, because it had an actuator that would allow, it was pointed to the south, but you could go from east to west, but no elevation, just azimuth.
Okay. All right. Have fun with that. Charles.
Okay. Are you hearing me? Yeah. Okay.
Yep.
All right. Yeah, I was just going to comment on the dish question there. A lot of times they just put regular screen wire under the top layup in in the gel coating on the dish. So sometimes you'll find that in the old C-band dishes. It'll eventually wear a corner or something, and you'll start catching on the screen wire that's buried in there.
Oh, so there's a mesh buried inside I wouldn't be able to see unless it wears down.
Yeah, it's like a
Okay.
layer in there sometimes.
Yeah, good to know.
Let's see. Haven't been up to too much. Been dealing with back injury, so I'm not going to be lifting anything for a while. So I'm not doing anything but just small projects inside mostly. Have been working on trying to get the VLF stuff set up for the eclipse tomorrow. Trying to get SDR Uno to work with. I've got a SDR Play Duo and about a 4x5 foot loop antenna, and so. But most of the time I get better results with the RF Space SDR IQ receiver, much cleaner picture. So we'll see which one I set up and leave for tomorrow, but I got some background data at least, so I know what it should look like on a quiet day versus a noisy day with flares, and then we'll see if that changes tomorrow. And of course, still running hydrogen on the dish, doing drift scans outside, but can't really. I was going to take my dish down and do some azimuth motor work, but not going to be doing that with my back in the shape it is at the moment. That's about it for me. So
Any good questions for Charles? Yeah, see you guys tomorrow. Anybody questions for Charles? Charles, you gonna be able to help me moderate tomorrow on the online?
I hope so. My internet service provider's been giving me some pretty strange rates and dropouts. So they tend to they've been going down for an hour to 2 hours at times unexpectedly. So I was kind of leery to be the only one helping. If that happened, that would be kind of bad. So you're going to be online too, Rich, and I mean, I can help people get in if you set me up that way.
Yeah, I'll be sort of online when those guys go out for breaks and stuff like that. We'll just keep the conversation going for the online people, and when they go off lunch and hunting for the eclipse, we'll keep that thing going.
Okay.
And we do have let's see. Somebody was asking about the Smith cloud, approximate celestial coordinates of these sources. What about Smith cloud? Jason from in the chat, and Edward also commented. Jason, you want to go over that question again?
Oh, I just saw that Edward had talked about some high velocity clouds that would be good sources for testing this kind of system out before you try M31 and M33. And I knew about the Smith cloud because I saw it. I saw an article on that. So I was just kind of curious what the celestial coordinates of some of those sources he was talking about were.
I can give you the Anticentre Shell coordinates in galactic coordinates. So it's
okay.
That's a longitude of 197 degrees, a longitude and a latitude of +2 degrees.
Okay. Sorry. So
that's 197 in longitude, and the latitude is +2 degrees.
And that's the
Anticentre Shell that Edward was mentioning.
Okay. And what's the like the center? What's the center velocity for that one? Is it like
That I don't know, but maybe while we're continuing talking, I can look it up. I probably can find it.
Yeah, I figured Smith Cloud would be kind of difficult because it's only like 75 minus 75 kilometers per second, so it's buried under the edge of the local signal. But
yes, yeah. By the way, I am looking up I had saved somewhere a list of the coordinates of these sources, but I have to look it up on my PC.
oh, okay.
By the way, the velocity of the Smith cloud, if I remember correctly, is about minus 80 kilometers per second.
Yeah, which is very close to the local signal, so
yeah,
that's going to be difficult.
Yeah, I just had a look at the spectrum, and it's a bit hidden in the local hydrogen.
Okay. All right. So you're saying that you look at the Smith cloud as sort of a reference point, and then you look at the M31 or M33. Is that the thought?
I think I think what Edward was saying was some of these other sources, not the Smith cloud, but a couple of these other sources are high velocity clouds that are fairly bright, and so they'd be a little bit easier to detect to kind of see that your system's working before you try, M33 or M31. But
so you do the off-axis, before and after, like you did with yours, and then you go for that source.
Yeah.
And same way. Okay. All right. That looks like fun. All right, Jack.
Oh yeah. Yeah, I basically two things. The first thing was I put that information after last month's discussion. I put that information on the FITS files. We kind of had that brief discussion about that. And I haven't seen a lot of chatter on it, so I don't know if it was of much interest, but I did put a representative samples of the FITS files that I'm getting off of basically off of Wolfgang's program and or the stuff that I got from him. And so that's one thing I've been doing. And the other thing I've been doing is I'm still heavily involved in converting over my positioning system that I based on DC motors with encoders that was in the journal year ago or so, and I'm converting that over to servo motors with a lot higher accuracy Hall effect sensors on the motors. So that's been an interesting challenge because obviously with the PID control in there, you've got to tune the response actually under load, and that's been kind of an interesting thing to do. But I've got it working in azimuth, and it's quite accurate. If I can get the hysteresis out of the gear chain, then it's extremely accurate. But anyway, I'm working on that, and I'm pursuing some for the altitude adjustment. I'm pursuing some linear actuators that are made by a company up in Canada that has Hall effect sensors on the motor that drives the linear actuator, and that'll then allow me to use the servo controller on that. And I'm using, as I mentioned, I think last time, I'm using servo controllers from an Italian outfit called Solo. These are Solo servo controllers. They're relatively inexpensive, but they do a really good job of PID control for the refinement of the ramping up without overshooting and all that kind of good stuff. So anyway, that's those are the two things I'm doing. And if there's any future discussion on the use of FITS files as kind of a standard, that would be fine. I haven't seen a lot of information on that come out of the group since I posted that stuff, but it's up there to look at.
Okay, any questions for Jack?
Yeah, I got one. Okay, so I'm looking here at solo motor controllers. That's the one, I assume. Right?
Right. Yep.
Okay. And what actual motor are you using?
Well, you've got a couple of different choices that you can use with that solo motor controller. One is to use a straight DC motor to which you've slaved an encoder, and the encoder can be either Hall effect encoders, or it can be incremental optical encoders. And I put those just on the. I get a DC motor that's got a dual shaft, and I put the encoder on the back shaft of the motor. That's one option. The really highly, the one that's more highly responsive and easier to tune is the what they call BLDC motors, which are servo motors, brushless DC servo motors, and all of those have built-in Hall effect encoders, and those can. The problem with that is getting one big enough that doesn't cost you a mortgage payment. But they're all geared down, obviously, massively. I've got pictures of the stuff that I've done, but I'm not quite ready to present it. But I am working right now on the software to basically convert over my other positioning system to this servo stuff. And when I get through with that, then I'll put that in the journal.
Okay. So you said BLDC motors. So that's a brand?
No, that's a type of motor.
Yeah.
It stands for brushless DC motor, and it's the solo controller handles those quite well. And
okay, so are those listed on? I'm going to look this up. Are they listed?
Yeah, if you look
on
them on,
solo?
if you look at either eBay or Amazon or whatever, and just type in BLDC motor, you'll see all kinds of different types there. You have to be careful that you get one that has got a torque rating that's sufficient to do what you need, even with the gear down. But
and it also has to have the encoder output, so you can plug it into this solo.
Yeah,
board,
most
right?
all of the BLDC motors have built-in encoders, but the easy way to tell is if it's got two cables coming out of the motor, then you've got encoders built into it. If it only has one cable, then it doesn't, or usually doesn't. But it'll say in the specifications whether it has the encoders.
All right. Thanks.
All right, great. Well, all right. And Wolfgang just added the position and velocity for S7. And so anybody needs to add another thing to their list of sources that they can calibrate with. All right. Okay, Wendy, I think you're last but not least.
Well, I've been distracted by a slight case of food poisoning.
Oh, gee.
So, well, these things happen. So, I just tuned in to see what was going on with you all. And glad of it.
That the health stuff getting in the way of radio astronomy is just, I hate that. Okay. Well, I hope you're better, and I'm glad you're here. Thanks very much.
What are you guys doing tomorrow about the eclipse?
Well, the Western Conference guys are in Dallas, so they're right under the eclipse.
Oh my gosh, I forgot about the Western Conference.
Right. They're gonna go out and get pictures. We got Rob Lucas from Australia, who's got all the eclipse equipment and cameras. So they're gonna go off searching for making sure they're, not in clouds, which is gonna be the big problem tomorrow. And so they're gonna work on that. And anybody else who's got an eclipse who can try to detect the eclipse, they're going to go for it, and hopefully they send me bunch of data I could put in the in time for the journal this month.
I saw on the Channel 8 news, they say they're sending up drones. Can drones go above the cloud cover? There must be a heck of a drone.
I think the problem is that drones, getting the drones to look up. They're going to put special cameras on them. But that'd be good.
Yeah, drones can look up. There's no problems. I have 5 drones, and one of them specifically designed to look up. When you get a chance, I'd like to talk about something very important that may add a lot of information to this group. I forgot.
Okay. Wendy, are you good? And I'm going to put Pablo on.
Yes, let's listen to Pablo, Destroyer of Planets. Was that the thing?
Detector, not destroyer.
It's still morning in Los Angeles, and I'm on a liquid diet, and tomorrow I'm going to be sedated. I'm not going to give you details why, but let's just say that I'm going to have to drink a lot of liquid tonight. But I forgot to tell you about artificial intelligence. And I think we should get into the artificial intelligence business here. I created GPT, an application for artificial intelligence for a photometric program that is used by scientists. And I think that artificial intelligence would be very useful to this group. In fact, I just looked, and there's one for radio astronomy. And what it can help us with, I mean, I think Sarah should create a GPT for Sarah where you dump all the information for people to eventually be able to look at all the data that we have, that Wolfgang has, and everybody else. So let me share the screen here for a second, if I may. Is that okay?
Absolutely. Go ahead.
Okay, this GPT here is a comprehensive data analyzer. And basically what you do, I'm going to bring a measurement table for one of the exoplanets, and let's pretend that I don't know what's in here. And I'm going to say, analyze this file and plot a graph based on relative flux target 1 over BJD TDB. This is one of the 1,000, and BJD TDB is baryocentric time for the sun. So it's gonna look into the data, and it's gonna analyze it, and then you can ask questions or massage it. And Wolfgang, maybe you can send one of your data files over chat. Can you see that, what it's doing?
Yeah, I can. Let me see. What?
So
I'm not sure.
Don't tell me what it is. I don't need to know what it is. It plotted the raw data over BJD TDB without even knowing what it is. And this is not even an photometric GPT. There are thousands. And then I'm going to show you the ones. There's only one for radio astronomy. But what you do is you can actually create a Sarah one where you put all the files, all that information, and then when people ask questions about radio astronomy, or they want to analyze data, it's going to do it. And you speak to it in English, in German, in Chinese, it doesn't matter. It knows it. So for example, if I look for a radio astronomy, found only one, this guy here. And it can be sophisticated, and it cannot, but I mean, the potential for artificial intelligence to what we're doing here is amazing. You can ask any specific questions, or you can have them analyze data, plot data, create pictures, create graphs, all in seconds. I'm paying $20 a month for thousands of GPTs. The point is that we should be looking into this to integrate our data and knowledge base, and so it can be disseminated. And actually, it's a useful tool for what we're doing here. Has anybody experienced a GPT? I don't want to take up too much of your time.
Yes, but I'm a bit skeptical about all of this, to be honest. And one concern that I would have is if you want to train like a large language model on like a bunch of radio astronomy data that we have collected, like we don't have like all that much data. And
well, but that's when you collect the data. One of the things that artificial intelligence can do, as you probably already know, is that it collects data from thousands of scientists and is able to detect patterns that only 1, 2, or 3 people or it's not able to do. For example, everybody talks about the negatives of artificial intelligence. What artificial intelligence can do is look at millions of mammograms from cancer, and it's able to predict before it happens based on millions of mammograms when somebody's going to get breast cancer. This is just one little thing. Same with this. It has a predictive feature to it that it's comparable.
That's so cool, but then in this case that you are like in this example that you're giving here, then there will be someone looking at the output who is very knowledgeable about I don't know, investigating these X-rays. So they will be able to see like, does it make sense, or is it just generating something that doesn't make sense? And I think this is going to be a big issue with that, like as long as these GPTs
absolutely, but that's true with any tool.
Prone to hallucinations, especially like we are amateurs, so we don't know everything about like we are not super experienced in what we are doing, so we might easily fall for these hallucinations.
Well, but that happens when you talk to a human as well. They may or may not know what they're talking about, or they may not have the comparable. It's up to you to do further research, but this is just a tool that it's able to gather zillions of data and able to explain. For example, I have to read a lot of PhD type presentations and or large papers, PhD papers. I can put it in there and it can condense it and explain to me in a way that I can understand it. Of course, it can be wrong, but anything can be wrong as well. But my experience with it is that it's able to gather data, plot data, incorporate data, see predictive, it has a predictive potential. It's incomparable. There are negatives, of course. Nobody denies that. But the positives are just amazing, especially for scientists, especially for amateur scientists, citizen scientists, or even PhDs. All I'm saying is I don't want to make a big presentation. I think it would behoove us to start looking into this, the plus and the minuses, but I think that the pluses overrule the minuses tremendously. If you have, because I've been playing with this for over a month now, and I can't even begin to tell you in an hour what this is able to do. It's a tool, it's like a calculator. Nobody knows the calculation tables anymore. Even Wolfgang won't be able to calculate the cosine of 1.335. He needs a tool to do that. I was an airline pilot. I never flew. The airplane flew. I used that as a tool. I just drove the airplane, but the airplane did all the work. Same with artificial intelligence. You can do amazingly bad stuff, but I think for data acquisition and knowledge, I think I should be working for these people. I'm a good salesman. Anyway, that's all I
But
have.
if I may comment on that, yes, artificial intelligence has found its place in astronomy and radio astronomy, and we are using it on a daily basis. But this is when we have data, and is run against a well-defined and well-trained model. So the application where we use it is we have our data which we search for fast radio bursts, pulses, and there's a model which knows how to interpret data, and it has been trained with many fast radio bursts. So we run it through it because physically going through that, or manually going through that would be just impossible. Just too many events that we have to analyze. And that's working very well. It does a prediction saying, okay, how big is the percentage that the event that we are seeing, the pulse, is a fast radio burst, and that works pretty well. However, without a good trained model, things get a little bit up in the air. So yes, there are its places. That's a well-established regime where artificial intelligence is thrown in. But just putting a, let's say, arbitrary data set into GPT, I'm afraid that would not be too helpful. I haven't tried it, but maybe I throw some spectrum into GPT and see what happens.
No, of course. And it has to be trained, it has to be curated, and I'm all for that. All I'm saying is that this is an amazing tool for radio astronomy, as you already found out.
All right. Well, maybe we need to get a little subgroup that can put this Chat GPT Sarah model together. That would be we'll work on that. I think that's a good idea. Okay. Anybody else? I miss anybody? All right. Well, we'll talk to everybody who's going to be at the Western Conference or online tomorrow. We got a lot of good presentations, and we should see a bunch of results on Tuesday from the guys coming back with their solar eclipse observations for tomorrow or for the conference. All right. Talk to everybody tomorrow, and see you guys in 2 weeks for the Drake's Lounge. Bye.
Goodbye.
Bye.
Bye.